Okay, this is Mr. Higley, and we are doing Chapter 13, Section 2 on flat or plane mirrors. Our objectives here in this video are to distinguish between specular and diffuse reflection, apply the law of reflection for flat mirrors, and describe the nature of images formed by flat mirrors. Okay, here we go. First of all, reflection is the change in direction of an electromagnetic wave at a surface that causes it to move away from the surface. Now, the texture of the surface is going to affect how light is reflected. Diffuse reflection is reflection from a rough or textured surface, such as paper or unpolished wood, or even the wall. If you look at the wall of the room that you're in, how are you able to see that? And that is because light is traveling in all directions towards your eyes from all parts of that wall. Okay, and so some of the light that's reflected off the wall is coming straight towards your eyes. If you were to consider moving a few feet, you would still see the surface of the wall because light is traveling, is reflecting off the wall at a different angle towards where you would be if you were to move. So this is what's known as diffuse reflection. Specular reflection is reflection from a smooth, shiny surface, such as a mirror, or it could be the surface of the water when it's smooth. But if you think especially of a mirror, if you look into a mirror, you see the reflection, you see the light that's reflected. But if you move, you will not see the same things. You will see different objects because light is only reflected in a particular way, and we'll look at that here. For reflected light, the angle of incidence, that is the angle between the ray that strikes the surface and a line perpendicular to that surface at the point of contact, that's our angle of incidence. The angle of reflection is the angle formed between the perpendicular to the surface and the light ray that travels away from that surface. And the angle of incidence is equal to the angle of reflection. That is known as the law of reflection. Okay? Angle of incidence is equal to the angle of reflection.
In optics, the law of reflection states that the angle of reflection of a ray of light from a surface is equal to the angle of incidence. The angles are measured from a line perpendicular to the surface at the point of reflection, as shown here.
Okay, flat mirrors form virtual images, and what that means is that the image is on the opposite side of the mirror from the object. Okay, so when you look at yourself in the mirror in the morning, you're looking at it, you're actually seeing an image of yourself which appears to be behind the mirror. The image will appear to be as far behind the mirror as you are in front of the mirror. And this is referred to as a virtual image. It's an image from which or through which no rays of light actually pass. A virtual image is created simply because that's where our eyes expect the object to be because of the way light travels, and we know that light travels in straight lines. And so this is the virtual image. Rays that converge on a point behind the mirror never really travel there, but they look to us as though they're coming from that point. That's referred to as the virtual image. If you were to put a screen in behind the mirror, you would never see an image on it. So virtual images cannot be displayed on a screen, whereas real images can be. And you'll see that here in this in our next animation. But here you see the pencil. The object is out here in front of the mirror. The image of the pencil appears to be as far behind the mirror as this pencil is in front of the mirror. If you were to lay a ruler from the mirror out to this pencil, it would look as though it were laying between the frame of the mirror and the image of the pencil back here. Okay, and you can see it in this diagram. A ray of light from this point of the pencil right here hits the mirror and comes back this way, and so your eye expects to see that image in a straight line back here. If you were looking from down here, the ray of light would strike the mirror and reflect according to the law of reflection. The angle of incidence is equal to the angle of reflection, and it would appear as though this point was back up here. Okay, so the image of the object, if you measure the distance from the mirror to the object, that's the same as the distance from the mirror to the image of the object. And the height of the image is the same as the height of the object. The height of the image back here is the same as the height of the object here.
When you go to the movies or when your teacher uses an overhead projector, the image that is being projected onto the screen is called a real image. Real images are formed due to the special properties of the lens or mirror used to create them. In the situation shown here, a converging lens bends many different light rays from a point on the tip of the pencil so that they come together at a point in another location. If you place a reflecting surface at that location, you will see an image of the tip of the pencil. A real image forms when many rays of light from an object come together at a specific location. Real images are often upside down when compared to the object. Another kind of image is called a virtual image. You are seeing a virtual image anytime you look in the mirror. Unlike real images, virtual images cannot be projected onto a screen. The law of reflection allows you to predict how light rays will travel when they reflect from a mirror. Light rays from here will change direction when they strike the mirror. Because your brain expects light to travel in a straight line from the object to your eye, the light appears to the viewer as if it came from here. Similarly, light coming from this point seems like it's coming from here. A virtual image is an image that appears to be at a location from which light does not actually come. These light rays seem to the man as if they came from behind the mirror, but they actually came from in front of it.